Hello and welcome to episode 5 of the Confounded Chronicles. This morning I'm taking video in my shed because it's Saturday morning. It's a day after I normally upload, and I didn't upload because I didn't have the cable to run my mill. There's only so much yabbering I can do without running the mill, and I've kind of done 2 videos of not moving it, so I wanted to get it moving this week, and I had to wait an extra day to get the cable in. So, cable's here, everything's hooked up, we're wired up, ready to go, and let's cut to some video that's not of my face. Let's go.
So parallel port cables have kind of gone the way of the dinosaurs, so I had to order this one online. Of course, what I had on hand was just male-male. I needed a male-female connector, so that's what we got. We plugged that all into the mill, plugged it into the computer, and this is the very first motion of the mill.
It lives!
Now at this point, I didn't have the backlash set up, I didn't have the steps per inch set up, I just wanted to make sure it would move. I hooked the Z-axis up, I didn't apply power to the other axes or the other drives, just to make sure if something went awry, I wouldn't be destroying all 3 of my drives. The Z-axis worked perfectly, so I went ahead and connected all the other axes up, set my steps per inch correctly, and we're going to adjust backlash later on in the video here. But what we're going to do first is lubricate all the lead screws. I'm just using some heavy grease and a brass rod to get in there and apply some lubrication to all the lead screws. With a manual mill, you don't really move it around all that much, so a lead screw system like this works fine. Your hands can compensate for the backlash and it works well. For CNC control, the motion back and forth is going to present a bit of a wear issue, which is why ball screws are the way to go for CNC conversions. So I'm going to try to minimize that by just keeping the lead screws well lubricated, adjusting the backlash nuts every X amount of time, and just keeping watch on it until we do the full ball screw conversion. So with all the axes lubricated, I moved everything back and forth to try to spread the grease around as much as I could, and we're basically ready to start adjusting for the backlash that we still have present. This is the real-time speed of the CNC. The Z-axis moves at about 45 inches per minute. Maximum, I think, rapid I can get is 60 inches per minute. And the XY table, I can get it up to about 100 inches per minute, but I think I have it set here at 85 inches per minute, just to help deal with cutting loads and to avoid missing steps. You don't want to be running right at the ragged edge of what's possible. Next up is just to make sure that our steps per revolution are correct and to see what kind of backlash we're getting. So on the X here, I'm looking at about maybe 2 thou of backlash, and then we'll move the mill around to measure the Y. And I would imagine the Y would be very similar because the axes are built very similar. And checking everything out, we can see we have about 2 thou of backlash. So I move basically up to 5 or 10 thou, and then I'll move backwards and see when the needle starts to move. And it's about 2 thou, which is phenomenal. It's a lot better than I thought I'd get with stock screws. The Z-axis is a little bit better just because you have the weight of the head pulling it down. It's just going to change a little bit when it comes to the motor or the cut load on it, but we'll go ahead in EMC2 here, and we'll set in our backlash settings. You have to go into the INI file, which is a text editable file, and your axes 0, 1, and 2 represent your X, Y, and Z axes, and you just put a backlash heading at the bottom of the other settings that you already have there, and set the backlash to whatever numerical value you're using. So it doesn't matter if you're using metric or imperial systems. In this case, I'm going to put 0.002 for X and Y and 0.001 for Z. So it's basically going to set 2 thou and 1 thou. And with that, you can run the mill back up and confirm everything works. So the Z-axis was almost bang on. We're maybe 2/10 out. And the X and Y, well, first the Y-axis was almost bang on. The Z-axis had a problem. I still was reading 1.5 thou, and I couldn't figure out why. So I jogged it back and forth while testing this little coupler. And once the table would move one way, it'd become loose, and move the other way, it'd become tight. Basically just means I haven't put enough preload on that little thrust bearing. It's kind of annoying to get to now with all my zip ties and cables and everything, but it's still four bolts, not that difficult. So what we'll do is we'll take it all apart, We're going to hold the lead screw. We're going to tighten the little spider coupler against the little aluminum thrust spacer, and that will, I'm assuming, take out the backlash that I'm seeing. So what I'm doing here is I'm just using a coupler on the other side to basically lock the lead screw and then using a wrench to turn that coupler tight. It's a fine line because you don't want to preload those bearings too much because you'll introduce some extra friction into the system, and you don't want to go too loose like I had it because then you'll develop backlash. I got it to a point where I think is perfect, and after confirming it, we see we're almost bang on. I've actually might have reduced the backlash slightly in the system, so we're going to see how that works for a while and see if we have to adjust the parameters after that. So that gets to this point. Next up, I have to adjust the fusion post to post correctly to EMC2. And then we're going to go ahead and start with a fixture plate. It's probably the first thing this machine's going to make. Lately, I've been really busy trying to finish up some custom projects. My lathe is a mess, which is why I haven't been able to put a ton of work into this mill. But this next week, all my custom projects will be tied up or finished up so I can put all my work into the mill. So once again, thanks for watching, and I'll see you guys next week. Take care.